All right, take two. Today we're talking about literal equations. Now, literal equations are any equation with more than one variable. The classic example is A plus B plus C equals D. Now, we can't actually really solve a literal equation because we don't have enough information. So usually the problems ask you to do something like solve for A, which generally means get the A on one side all by itself. Now, keep in mind that all of the rules that we already know still apply. I'm going to write that in red because it's very important. All the rules that we know still apply to literal equations. So, while this looks intimidating, it really is no different than solving something like 1 plus 2 plus 3 equals 6. What do we want to do here? Well, if the goal is to get the 1 by itself, we would subtract the 2, subtract the 3. That's the subtraction property of equality. If we subtract it to one side, that means we have to subtract it to the other as well, which gives us 1 equals 6 minus 2 minus 3. The problem above, A plus C, B plus C plus equals D, follows the same basic idea. We have A plus B plus C equals D. We can subtract the B, subtract the C, and so long as we do it to both sides, we end up with the same equation. Let's go ahead and try a few more examples from the homework. This is number 2. We have, I'm going to write it in purple because I'm going to live my life that way. We have Z equals 3 over 2x. We want to solve for x. Well, what's our goal? Get x by itself. Excuse me. What's keeping the x from being by itself? The 3, the 2, and the fact that it's in the denominator. Well, believe it or not, these are all manageable problems. We just have to kind of work our way through it. The first thing we should do is get the x out of the denominator. Notice, since x is being divided, the opposite of division is multiplication. So let's multiply x to both sides. Now, this is one of those things that it's going to help you out in the future if you get in the habit of it. If you've got a denominator and you're multiplying, multiply by the whole denominator. It'll just keep things a little bit more simple for the future. So in this case, I'm going to multiply by 2x. Notice I'm multiplying by two things at the same time, which is the multiplication property of equality. And that's totally fine. You'll find a lot of times in these problems you end up kind of doing things like this at the same time. So we end up with 2xz equals 3. Well, our goal is to still get x by itself. What's keeping it from being by itself? The 2 and the z. So let's go ahead and divide the 2 and the z. The reason we chose division is because the operation between the 2, the x, and the z is multiplication. If we divide one by 2z, we have to divide the other by 2z. I don't know why I drew those equal signs. We don't need them at the moment. We get x equals 3 over 2z. There's our answer. Honor students don't like problems like this because there isn't a very neat answer. However, we can't reduce that any further, so we'll just leave it like that. This was the division property of equality that I used. We'll try one more example problem. Maybe, if it'll cooperate. No, I don't want to select that. There we go. We're going to do number 6. Now, number 6 is the trickiest problem on the whole homework. And so we'll just go ahead and work our way through it right now. Talk about a few things along the way. We have z equals b plus m over a. We want to solve for a. I'm going to switch colors. Now, what's keeping a from being by itself? Well, we've got the fact that there's a b, there's an m, and the fact that the a is in the denominator. Let's go ahead and take care of the b first. The reason being, if this problem was something like 3 equals 1 plus 10 over a, the first thing we'd want to do is get rid of the 1 to the other side. So with the same logic, we're just going to do the same thing. Let's get z equals b plus m over a, subtract b, that's a subtraction property. We end up with z minus b equals m over a. Okay. I think the next thing we should do is get the a out of the bottom. Now, since it's being divided, what's the opposite of division? Multiplication. So we'll multiply both sides by a. Notice I added a pair of parentheses. The reason I added parentheses is that's my way of making sure to say that the a is being multiplied by both the z and the b through the property of distribution, right? So this works nicely for now. We end up with a z minus b equals m. We'll close the parentheses. Okay. Well, now if we want to get the a all by itself, we can simply divide by z minus b. Since z minus b is contained in the parentheses, and the only operation between the a and the z minus b is multiplication, we can divide. Which gives us a equals m over z minus b. Now, number 6 is the trickiest problem on the homework. It's also probably tricky enough that I wouldn't necessarily put it on an exam. Literal equations is in our core. We have to cover it. I don't think it's the thing we're going to spend a lot of time focusing on. So make sure you understand what's going on. Make sure you're following the rules that I'm doing. But don't stress yourself too much over the intricate details of this. We'll talk more about the applications of literal equations tomorrow. In the meantime, just do your best, study this, and if you have additional questions, let me know.